This is Ashish. So I wanted to ask, does the assignment one have some questions that have multiple correct answers? Mm-hmm. Mm-hmm. Yeah. Okay, but they can have multiple correct answers. Sure.
Um, I guess we can start. I'll just share. Do you guys have any doubts from the lecture itself, or should I just discuss the assignment questions?
Yeah, I have one doubt.
Yes, tell me.
Yeah, the distal end and the proximal end wasn't clear, and how they were like helping us deduce the insertion point. Can you go over it again?
Okay. Just let me share the slide deck. Okay. Um. So. Okay. This is what you are talking about, right?
Yeah, yeah.
Yes. Okay. The distal and proximal end here is with respect to the torso or the subject itself. So, if it's further away, then it's supposed to be distal. If it's closer to the body, it's supposed to be proximal. But that is a relative description of sorts. Uh, in a
Okay.
normal case scenario, if there is no description of what the point of reference is, always assume that it's the subject or the body itself, and whichever point is closer is the proximal point and the further one is the distal point. Does that make sense?
Yeah. So how do we know about the insertion point about the muscle?
Insertion point is always the distal point, and the origin point is always the proximal point. So, in this case, the force is being applied at the distal point, which is on the radius ulna, and therefore this is the insertion point, whereas the humerus, where the other end of the muscle is connected, is the proximal point because it's towards the force is towards that point. Does that make sense? Kind of.
Yeah, yeah,
Okay,
yeah.
cool.
Thanks.
Any other doubts? No? Okay. I will just share the older assignment questions once. Okay. Yes. Can you guys see the slides?
Yes, we can.
Okay. So, coming to the first question, simple. If select whatever is the correct statement, force is a vector, versus a scalar, unit of force is Newton meter, or all of the above. With the correct answer is force is a vector. Um, Now, for this, so here the theta is, okay, doesn't work. Theta is supposed to be 30 degrees. Uh, so we saw that fx is uh, f cos theta. You guys should have seen the derivation for that. Fx is cos theta and fy is sin theta. F sin theta. So the answer should be, okay, sorry, my thing isn't working. Okay. So, f, okay, it doesn't work. Anyways, fx would be therefore 10 uh, cos theta, which is 10 cos 30, uh, which would be uh, cos 30 is root 3 by 2, so it will be around 8.66, and uh, fy would be f sin theta, f, so 10 by 2, therefore 5. Make sense? Questions? Okay, moving on. Okay, so in this question there is a slight twist. So the force that is acting is 90 degrees to the link. So this theta that is given as 30, the force is actually okay, no, never mind, it's okay. uh, Consider theta to be 30 degrees, and then we need to calculate the for the fx and fy components of the force, and similar to the previous problem, it would be, okay, it should be 43 and 25 minutes, sorry about that. um Next, so uh, uh, in the following figure, what are the forces that a point A will be subjected to? So this is the applied force, uh, and A is a sort of a cantilever. So it's stuck into the wall. So there are two reaction forces, Rx coming in the x direction, ry in the y direction, and there is a moment that is also there because it's present, it's stuck to a wall. So the answer would be two reaction forces and a moment. Next, match the following. Simple. Uh, Shoulder joint, uh, wrist joint, ankle joint, and elbow joint. Which of these joints mean what? Shoulder joint is ball and socket joint. Wrist joint is uh, ellipsoid joint. Ankle joint is a plane joint, and elbow joint is a hinge joint. Uh, Next, so we saw that there are multiple types of livers, and depending on what like class 1, class 2, and class 3 types of liver, and depending on what where the force, the fulcrum, and the resistance is, that defines whether the situation will have a mechanical advantage or whether it's going to a mechanical advantage or therefore a change in the effort, or if it's going to change the speed and the range of the movement of the subject. So in that scenario, we saw that there are certain conditions where there are mechanical disadvantages, certain conditions where there are mechanical advantage, and the and depending on where the positioning of fulcrum, force, and the uh, resistance is, you will you can calculate and get to know whether this is actually a mechanical advantage and disadvantage. Okay, coming to correct statements, levers are only used to reduce effort, which is not true. It can have advantage or it might be a disadvantage, but theoretically this is not true. Levers are only used to increase the range of movement, also not true. It's a compromise between the range of movement and speed and the mechanical advantage or the effort. So the correct answer is levers could sometimes cause mechanical disadvantage. They don't always cause mechanical advantage. Okay. Uh, which of these are false in regards to levers? In class 1 lever, the fulcrum is at center with one side as the force arm and one side as the resistance arm. In class 2 levers, the effort is applied at the center, which is not true. The resistance is what is present at the center. In class 3 lever, the resistance is not at the center, it's towards one of the ends, and the fulcrum is towards on the other end. In class 1 lever, the resistance is at center, which is not true, the fulcrum is. So these are the answers. Okay. So which is this is an example of which kind of lever? The basically the axis is here, the resistance is here, this is the resistance, and the force is here. So this is a class 2 lever. Okay. Uh, can anyone hazard a guess for this question? The torque is exerted at point A and torque at point A due to a force 10 Newton applied at point B in this direction. What would be the answer? Can anyone?
0 newtons. 0 Newton
Yes.
meter.
Because torque torque is always calculated in the perpendicular direction. If the force applied is perpendicular to or at an angle to the object, not at 180 degrees or at 0 degrees. The same would be true if the force was applied this way. If it was a, instead of pulling force, it was a pushing force. And can anyone answer this? Anyone?
OX is minus F cos 45.
No.
It's
No. So the direction of F is in the in line with the x-axis. So and so basically, if you were to split F to its Fx and Fy components, Fx would be equal to F, and Fy would be equal to 0, because it is not an angle with the, if it were applied here in this direction, it made sense if it's F sine 45 or cos 45, either of them. But it's not in this direction, rather it's in this direction. The absolute magnitude of OX therefore will be F and OY would be 0. Which is the answer. If anyone has any doubts or if they want me to go through the lectures, they can tell me, because that's what this class is for, of sorts. Any doubts? Do you want me to go through the lecture slides once?
no, not really.
Okay, cool. Then I'll try to have more questions from the next time. Supposed to be a doubt clearing session also. If there are any doubts, please let me know. Okay, cool. I will share the questions that I discussed. What is the deadline for the assignment submission for week 1?
5th of February, I guess.
Okay, then the week after that, probably I can discuss the questions once if needed, if there are any questions as such. Okay, thanks, I guess. If does anyone have any other doubts? No. Okay, cool. Thanks. Bye. Sorry, what do you mean reach out?
How to contact TA?
I am the TA. You can ask your, if you have any doubts, you can ask here. These sessions are for that.
Like, can we submit doubts via email or something like that?
I don't think that's an option. Just, I will be taking classes on Mondays, and there is one more TA who is supposed to take classes on Tuesday, I think. So you can join in one of the classes and ask your questions.
Okay, ma'am.
Okay. Thank you.